Hi, it's Miss Mary Ellen at the Randolph Township Library. Welcome back to STEAM Explorers. You know, the weather's getting a little bit colder, and I started thinking it won't be long until we have some mornings when the roads are icy. And I got thinking about ice. Now, if you had an ice cube, what would you do to melt it? You could run hot water on it. What else could you do? You could use a blow dryer, right? You could put it out in the sun. But when there's ice on the road, what do we do to melt it? Or if you have ice on your sidewalk at home? Usually we put salt on it. But why does that work? Salt isn't hot. Salt isn't the same thing as putting hot water on it. So how does that work? So I thought it would be fun to find out a little bit about ice and what makes salt melt ice.
Before we go any further, let's review the scientific method. The first step in the scientific method is asking a question. Then we come up with a hypothesis, or what we think the answer is going to be. Then we do an experiment. After the experiment, we analyze our results and come up with a conclusion. Was our hypothesis right? If it wasn't, we might do another experiment to try to come up with a better answer.
Okay, so before we come up with our hypothesis, we might need to learn a little bit about ice. Because remember, a hypothesis isn't just a crazy guess, it's considered an educated guess. So we should know something about how ice freezes. Do you know what temperature water freezes into ice? It's 32 degrees Fahrenheit, which is the same as 0 degrees Celsius. And that's no accident. They made the Celsius temperature scale to start at 0 being the freezing point of water. When you have ice on a road, there's a thin layer of water on top of it, okay? And that can also happen a little bit because it's melting, and also things like friction from car tires will melt a little bit on the top layer. So you have water on the top that's melting the ice under it, and the ice underneath, which is freezing the water over it. And they stay in balance. It's called equilibrium. But between the freezing and the melting, it's a balance. But when we add salt into the mix, we put salt on the top layer, that makes salty water. Well, guess what? Salty water freezes at a lower temperature than just regular plain water. That's called freezing point depression, which is really just a fancy way of saying that it freezes at a lower temperature than 0 degrees Celsius. I wonder if other things cause freezing point depression. Let's do an experiment and find out. Okay, so now we're going to do an experiment. We're going to put 3 different cups in the freezer with different things in them. Okay, so the first one is just going to be plain water. Okay, and I'm going to put 2 ounces of water in, which is a 1/4 cup. And you might be wondering, why are we just putting in water when we're trying to see how things change, how water freezes? But we need something to compare the salt and the sugar ones to. In science, that's called having a control. Okay, so this one is just going to be plain water. Okay, now I'm going to put a 1/4 cup in the other 2. So this is 1/2 cup. If you have a 1/4 cup measure at home, that might be easier to use. Okay. So I have the same amount of water in each of these cups. Now the one that says water, I'm just going to leave alone. The one that says salt, I'm going to mix about a tablespoon of salt into this. fact, it's so much salt it doesn't completely dissolve. But that's good. That means that we have what we call a saturated solution. Okay, no more salt will actually even dissolve in here. Okay, that's as salty as it can be. Now I'm going to do the same thing with the sugar. And again, that is a saturated solution. Okay, I'm going to go put these 3 in the freezer.
Now it's time for our hypothesis. Which do you think will take the longest to freeze? Okay, I've had these in the freezer here in the library for about an hour and 20 minutes. Let's see how they're all doing. This is water. It looks pretty frozen. The sugar one not all the way frozen, but it's kind of slushy. But the salt one, it's a little bit of slush, but it's really mostly just water still. Now it's time to analyze our results. Was your hypothesis correct? Did you predict which solution would take the longest to freeze? The reason that this happens is that when water freezes into ice, it forms a crystal structure. The molecules that are dissolved from the salt interfere with this process.
It would be like if you tried to put Legos together, except there were other little bits in the way so they wouldn't connect.
So what is our conclusion? We found that salt, or sodium chloride, does lower the freezing temperature of water. In fact, this kind of salt can lower the freezing temperature of water to about 15 degrees Fahrenheit, which is about negative 9.4 degrees Celsius. If it gets colder than that, road crews need to use different types of chemicals to melt the ice on the street.
Okay, here's the fun part. We're going to make ice cream. Okay, for this, the instructions and everything that you need are on the paper that you picked up. And if you didn't, you can just follow along with me. So I have a quart Ziploc bag and a gallon Ziploc bag. Okay. In this bag, I'm going to put a cup of half and half. Okay. You could use heavy cream if you wanted, but half and half is fine. I never actually did it with cream. I did it with half and half. Okay, so I have a cup of half and half. And of course, this is a clean new bag I'm using. Now, at home, you probably have measuring spoons that I don't have here, but about a tablespoon of sugar. Let's say that's about a tablespoon of sugar. And about a teaspoon and a half of vanilla, okay? It doesn't have to be pure vanilla extract, just whatever you have in your kitchen is fine. Okay. I'm going to put this in. Now I'm going to seal this really carefully. I'm going to try to get as much air out of it as I can. Okay, the important thing is to make sure that it's sealed really tight. Okay, now I'm going to put this into the gallon bag that I have. But I need to make this really cold so that it will turn into ice cream. So I have ice. I'm going to fill it about halfway with ice. And then I also have salt. And I'm going to add the salt because, as we learned, adding salt makes the temperature get a little bit colder than the actual freezing temperature of 0 degrees Celsius. And that's what we need for the ice cream, because the ice cream is not water. It's actually cream, and it has sugar in it. So remember what we talked about, that because it has all those other things in it, it may have a depressed freezing point also. All right, so I'm going to put a little bit of salt in, maybe about 1/4 cup or so. And I'm putting this, of course, in the outside bag, not putting the salt in my ice cream. That would be yucky. Okay, now I'm going to seal this up. And again, seal this tightly, okay? You don't want this spilling out, having icy, salty water in your house, okay? That's a mess. Okay, now we're going to shake. And because this could get really cold, you might want to have a towel or something to wrap it in. Okay, so I'm going to shake. And this may take a while, okay? So we're going to keep shaking. If you get tired, you can have a friend help you. Okay, I've been shaking this now for about 10 minutes. Did you have to add more ice to yours? I had to add more ice to mine. And I hope you were using a towel or mittens or something so you didn't get your hands too cold. Okay, so here's the fun part. Don't want ice in it. So now I'm going to open up my inside bag and scoop it out with my spoon. If you only shook it for maybe about 5 minutes, it might be more like soft serve. That's good too. Okay. Some of you might have an ice cream maker at home, and if you do, you know that you put salt and water in the outside canister. But here's a way you can make ice cream yourself at home. It's pretty good. Okay, so this is Miss Mary Ellen at the Randolph Township Library. Thanks a lot.